Good morning everyone and welcome to the first online class for physics. I request every student to kindly watch this video from starting till the end. Please do not watch this video fast forwarding. Today let us begin a new chapter, that is chapter number 2, motion in one dimension. Okay, listen. There are two types of things in this world. One we may call as physical quantities and the other we may call as non-physical quantities. Let me explain you with the help of an example. Suppose as you get up in the morning, you go to your mother and ask, "Mummy, prepare for me a glass of milk." Your mother is scolding you for not washing your face. You are very angry. From the above example, let us take two things. Number one, glass of milk, and number two, your anger. You can measure a glass of milk using a measuring jar or a measuring beaker. But you cannot measure your anger. So, the objects which we can measure is called as physical quantities. For example, milk, sugar, length, weight, etc. And those quantities which we cannot measure, only you can feel it, are called as non-physical quantities. Example, your anger, hatred, love, etc. So, in this chapter, we are dealing with physical quantities that which we can measure. Physical quantities can be classified into two categories. Number one, scalar quantities, and number two, vector quantities. I know that we have already studied it. Still, let us study it one more time. Number one, scalar quantities. Scalar quantities are those quantities which are expressed only by their magnitude. What do you mean by magnitude? I will explain you with an example. If I earn 50,000 per month and my brother earns 1 lakh per month, and then who earns more? What a funny question, right? Obviously my brother. But why? Because 1 lakh is more than 50,000. Everybody knows it. Yes, that is magnitude. The numbers 1 lakh or 50,000 is the magnitude. Still having doubt? One more example. If you go to market for buying 10 kg of rice, then the number 10 is the magnitude and kg or kilogram is the unit. So we need two parameters to express a scalar quantity. Number one, numerical value or magnitude. Number two, unit in which quantity is being measured. Mass, length, time, distance, velocity, etc. are the examples of scalar quantities. Now number two, vector quantities. Vector quantities are those physical quantities which need magnitude as well as direction to express it. For example, if I ask you to move 10 meters away, you will have doubt whether to move towards north, south, east or west. But if I ask you to move 10 meters east, here we have three parameters to express a vector quantity. Number one, numerical value or magnitude. Number two, unit. Number three, direction. Some of the examples for vector quantities are displacement, velocity, force, acceleration, etc. Usually during examinations, quantities will be given and you have to identify them as scalar or vector. Have you heard the terms rest and motion? Surely you know what it is. If you don't move, you are at rest. If you move, then you are in motion. Okay, right. At present, what are you doing? You are sitting and listening to my class. So you are at rest, right? But listen carefully. If we take the world as a whole, are we not moving along with the world? Surely we are. Even though we are sitting in our room, we are not rest relative to the universe. We are at rest only relative to our room and our immediate surroundings. Okay, let us take another example. We are sitting in a moving train. We are at rest relative to the train compartment, but we are in motion relative to the outside as we are moving along with the train. So we can define rest and motion as a body is said to be at rest if it does not change its position with respect to its immediate surroundings, while a body is said to be in motion if it changes its position with respect to its immediate surroundings. Now, what do you mean by motion in one dimension? If a body is moving along a straight line path, then the motion is said to be one dimensional. For example, a car is moving on a straight road, then the motion of car is one dimensional. If a body is moving along a curved path, then the motion is two dimensional. For example, if a car is moving in a curved path, then the motion is two dimensional. Now let us study three pair of terms, and these pairs look similar but they are different. Number 1, distance and displacement. Number 2, speed and velocity. And number 3, acceleration and retardation. Number 1, distance and displacement. Let us take an example. A car is moving from A to B, which is of 10 kilometers, and then B to C, that is of 15 kilometers. On traveling that car from A to C, it has covered a total distance of 10 plus 15 kilometers, that is equal to 25 kilometers. So, distance is equal to 25 kilometer. That means it has magnitude and it has unit. So, distance is a scalar quantity. Now, what is displacement? Displacement is the shortest distance from the initial to the final position. So, in the above example, displacement is the length of the straight line between A and C. Let us take it as 17 kilometers. So, displacement is equal to 17 kilometers towards south. It has magnitude, it has unit, and it has direction. So, displacement is a vector quantity. SI unit of distance and displacement is same as the SI unit of length, that is meter. Please do remember some of the important points. Number 1, distance is a scalar quantity and displacement is a vector quantity. Number 2, if motion of object is along a fixed direction or a straight line path, the distance and displacement will be same. Number 3, if a body is traveling in a circular path, displacement will be 0 as initial and final position is same, but distance can be calculated. Now, let us study about speed and velocity. As you have already studied distance and displacement, it will be easy for you. The formulas for speed is equal to distance divided by time, and the formula for velocity is equal to displacement divided by time. Therefore, we can easily say that speed is a scalar quantity and velocity is a vector quantity. Now let us study some of the important terms related to speed and velocity. Number 1, uniform speed. If a body covers equal distance in equal interval of time throughout motion, then it is called as uniform speed. Now uniform velocity, the definition remains same, only you have to specify the direction in the definition as it is a vector quantity. That means if a body covers equal distance in equal interval of time in a particular direction is called as uniform velocity. Second term, average speed. The ratio of total distance to the total time is called as average speed, and average velocity, the ratio of total displacement to the total time is called as average velocity. Now the third term, instantaneous speed. Instantaneous means at any instance. The definition of instantaneous speed is If a body is moving with variable speed, variable means changing. Speed at any instance is called instantaneous speed. Once again, the definition for instantaneous speed: if a body is moving with variable speed, the speed of the body at any instant is called as instantaneous speed. And instantaneous velocity definition: if a body is moving with variable velocity, the velocity of body at any instance is called as instantaneous velocity. Let us revise the important points from this part. Number 1, speed is a scalar quantity and velocity is a vector quantity. Number 2, for a motion in a straight line, the magnitude of velocity is same as speed. Number 3, average velocity of body can be 0 even if average speed is not 0. Now, let us study acceleration and retardation. Definition of acceleration is rate of change of velocity with time. That means acceleration is equal to change in velocity divided by time. And the unit for acceleration is equal to unit of velocity divided by unit of time. And we know unit of velocity is meter per second and unit of time is seconds. And therefore unit of acceleration is equal to meter per second square. The formula for acceleration is change in velocity divided by time. That is equal to v minus u divided by time, where v is final velocity, u is initial velocity and t stands for time. Remember, negative acceleration is called as retardation. Let us understand it better with an example. Suppose a car initially moving with a velocity of 50 km per hour, and then when it enters a city, its velocity decreases to 20 km per hour. Here, acceleration is equal to 20 minus 50 divided by time. Then the answer will be minus 30 divided by time. So the answer is negative. So when acceleration is negative, it is called as retardation. Speed is decreasing with time. Now the final term, that is acceleration due to gravity. We know everybody above Earth's surface is pulled by the Earth due to gravitational force. So if any body falls from above to the Earth, its speed will increase due to the pull of Earth, which we call as gravitational force. Thus, when a body falls freely under gravity, the acceleration produced in the body due to Earth's gravitational force of attraction is called as acceleration due to gravity. It is denoted by the letter g. If body falls down, g will be positive, and if body moves vertically upwards, acceleration or g will be negative. Average value of gravitational force is equal to 9.8 meter per second square or nearly 10 meter per second square. Please remember, value of g does not depend on mass of body. So if two bodies of different masses are simultaneously dropped from same height in vacuum, both will reach the ground at same time in vacuum because there is no effect of friction and buoyancy due to air. And that is the end of today's class. Thank you. Have a wonderful day.